Today I'm going to explaining what is a frequent pattern growth algorithm. This algorithm is an improvement to the a priori method. A frequent pattern is generated without the need for the candidate generation. FP growth algorithm represents the database in the form of tree called the frequent pattern tree or FP tree. And the frequent pattern tree is like a tree like structure that is made with the initial item sets of the database. The purpose of the FP tree is to mine the most frequent pattern. Each node of the FP tree represents an item of the item set. The tree structure will maintain the association between the item set, and the database is fragmented using the one frequent item. And this fragmented part is called the pattern fragment. The item set of these fragmented patterns are analyzed. Thus, with this method, the search for the frequent item set is reduced comparatively. In these slides, I'm going to explaining what are the challenges of frequent pattern mining. The challenges were the multiple scans of transaction database and the huge number of candidates and tedious workload of support counting for database. And how we are going to improving the a priori the general ideas were reduce the passes of transaction database scans and shrink the number of candidates and facilitate supports counting of candidates. The main reason for FP tree is that construction of the frequent pattern tree is a time consuming activity. Further, FP tree based approaches do not offer flexibility and reusability of computation during the mining process. Now I'm gonna explain the benefits of FP tree structure. Completeness. It preserves the complete information for frequent pattern mining and never breaks a long pattern of any transaction. And compactness is reduce the irrelevant information in frequent items are gone. Never be larger than the original database and not count the node links and the count field. One FP tree path may correspond to multiple transactions. Tree is never larger than the original database. And the main advantage of the FP growth algorithm is the pairing of item is not done in the algorithm. It makes it faster, and database is stored in the compact version in a memory, and it is a efficient and scalable for mining both long and short frequent patterns. And this algorithm needs to scan the database only twice when compared to the a priori, which scans the transaction for each iteration. Now I am explaining the weakness of the FP tree growth. The support dependent and cannot accommodate dynamic support threshold and cannot accommodate incremental DB update, and mining requires recursive operation, and it may be expensive, and when the database is large the algorithm may not fit in the shared memory. FP tree is more cumbersome and difficult to build the a priori. At last, I'm explaining why is frequent pattern growth fast. Performance study shows FP growth is an order of magnitude faster than the a priori. The main reason were there is a no candidate generation and the no candidate test. Use a compact data structure, eliminate repeated database scan, and basic operations are counting and FA tree building. In conclusion, the a priori algorithm is used for mining association rules. It works on the principle the non-empty subsets of frequent item set must also be the frequent. Frequent pattern growth algorithm is a method of finding the frequent pattern without the candidate generation. It constructs the FA tree rather than using the generate and test strategy of a priori. The focus of the FP growth algorithm is on fragmenting the path of the items and mining frequent patterns.